Diodes can be broadly classified into two categories: ordinary diodes and special diodes. Ordinary diodes, they are used for their unilateral properties, rectification properties, like diodes used in the design of rectifier circuits, in the design of switching circuits, in the design of clippers, in the design of clampers, and many more applications are also there for ordinary diodes. When it comes to special diodes, they are used for their properties other than rectifier property. For example, in tunnel diode, it is used not for its rectification property. It is used for its dynamic negative resistance property. Hence, it is a special diode. Similarly, varactor diodes, they are not used for their rectification property. They are used for their voltage dependent transition capacitance property. So varactor diodes fall in the category of special diodes. Similarly, Zener diodes, LEDs, photodiodes, these are all special diodes. When it comes to ordinary diodes and their rectification property, they allow current to flow through them when the bias is forward, and they prevent the flow of current when the bias is reverse. This property is used in converting AC into DC. Other applications are also there for this property. Clippers, clampers, they also use this property of the diodes in their functioning. Clippers, also known as slicers, they are mainly to remove, to delete a portion of the waveform. This portion may be above or below a certain voltage level, and this voltage level may be positive or negative. When it comes to clampers, these circuits also use diodes, ordinary diodes. Their functioning is mainly to alter the DC level of the waveform. Certain amount of DC is added to a waveform, or it may be subtracted from the waveform, changing or altering its DC level. Diode applications, clippers and clampers, series on the semiconductor devices and circuits, lecture number 2.16. Clippers and clampers. These are two different types of diode circuits. They use ordinary diodes in their design. Clippers are mainly meant for deleting a portion of a waveform. This portion may be small or it may be large. This portion may be on positive side or it may be on negative side. Clampers, these are also simple circuits using ordinary diodes. The main purpose of clampers is to change the reference level of a waveform. It means they add DC or they add positive DC or negative DC, thereby changing the DC level of the waveform. Now we move further to begin the session. We begin the session with a few introductory remarks on clipping circuits. Clipping circuits are used to select for transmission that part of an arbitrary waveform which lies above or below some reference level. Other names are also there for clippers, limiters. They are called limiters. They are called slicers. They are also called amplitude selectors. Essentially, they remove certain portions of the waveform near the positive or negative peaks or both, allowing a part of the waveform to pass through means removal of the remaining part of the waveform. So in the first point, clippers are defined as circuits which allow transmission of a waveform which is above or below certain voltage level, reference level. In the second point, the definition is with respect to their action. Their action is actually removal of a portion of the waveform. Clipping can be done either at one level or two levels, and it alters the shape of the waveform and consequently its spectral components. Notice, in clipping, shape of the waveform is altered. In clamping, it is not so. Only DC level is changed. Some more points regarding clipping circuits. Clipping circuits usually consist of non-linear elements like diodes, transistors, along with the linear elements like resistors. The diodes are non-linear, resistors are linear. Clipping circuits use both non-linear diodes, transistors, and linear resistors. Energy storage elements like capacitors are not used in clippers. Diode clippers may be used in pairs to perform double-ended limiting at independent levels. A series parallel arrangement may be used. So if series arrangement is used, it is series clipper. If parallel arrangement is used, then it is parallel clipper. Series clipper circuit is one in which the diode is connected in series with the load, and if the diode is in a branch parallel to the load, then it is called parallel clipper. Diode clippers can be grouped into positively biased and negatively biased. Here are shown circuits, clipper circuits. A and B, these two circuits clips away positive peaks. C and D clips away negative peaks. How they are able to do this? To understand their operation, consider circuit in A, clipper circuit shown in A. To understand the functioning of the circuit and other circuits too, we have to keep in mind when the diode is conducting, output voltage is VB, irrespective of input voltage. When diode is not conducting, output voltage is equal to input voltage. This is true in case of A, in case of B, in case of C, in case of D also. To understand further the functioning of these circuits, we assume input voltage is pure AC sinusoidal, like this. We consider one cycle of the input voltage. It is consisting of two half cycles, positive half cycle, negative half cycle. During positive half cycle, when the input voltage reaches VB and moves further higher, the diode starts conducting. So the output voltage gets clamped, gets fixed at VB, and this continues as long as input voltage is above VB. When the voltage falls back to VB and further lowers, the diode goes into non-conducting state. When Vi falls back to VB, the non-conducting state of diode comes into being from conducting state, and from that point onwards, V naught equal to Vi. This is the story when the input voltage is positive during positive half cycle of the input voltage. During negative half cycle, the diode never gets a chance to be on. Therefore, V naught is always Vi. So net result is during first cycle of the input voltage up to VB, output voltage is same as input voltage, like this. And when input voltage falls below VB, once again the output voltage becomes input voltage, like this. During the next cycle, again same story. A part of the positive half cycle, it gets removed. Negative half cycle, it gets transmitted as usual. So notice here the positive peaks are being removed. In circuit B also, function of the clipping is done in the same manner. Here, clipping starts at a negative voltage. Here, clipping is at VB positive voltage, whereas in B, clipping is at negative voltage minus VB. So, major portion of the input waveform, it gets clipped away. In C, negative peaks are clipped away. In D, negative portion is clipped away, but clipping starts at a positive voltage. Therefore, major portion of the waveform is clipped away. Now, explanation. Positively biased diode clipper. Positive peak clipping at a positive or negative voltage happens in these circuits. When Vi is more than Vb, diode is conducting and V naught is Vb. When input voltage is more than Vb, diode starts conducting. When diode starts conducting, output voltage is same as Vb at one level. Otherwise, V naught is equal to Vi. Output voltage is equal to input voltage. Positive peak clipping at a negative voltage. In this circuit, a short circuit output will result in a large current being driven through the diode by Vb and may damage it. Here a point of caution is being given when we use positive peak clipping at negative voltage B, circuit B. Now, negatively biased diode clipper. Negative peak clipping at a positive or negative voltage. When VA is less than VB, diode is conducting and output voltage is equal to VB. Otherwise, V0 is VA. This point, first point here, first point in the previous case also, it is mentioned in the beginning of the discussion on clippers. When diode is conducting, output is VB. When it is not conducting, output of the clipper is input voltage. This is the basic point, fundamental point to understand the functioning of clipper circuits. Next, negative peak clipping at a positive voltage. In this circuit, a short circuit output will result in a large current being driven through the diode by Vb and may damage it. It's a point of caution. The waveforms, input waveform and output waveform of different clipper circuits are shown. See circuit A, B also, they belong to positive peak clipping category. C and D belong to negative peak clipping category. In A, clipping is at positive voltage. So from this level, this is actually VB. Above VB, whatever waveform is there, it is removed. In B, clipping starts at minus VB. So major portion is removed. In C, clipping is at minus VB, but lower portion is removed. Negative peaks are removed. In D, negative portion of the waveform is removed, but clipping starts at positive voltage. Here, it is VB. Some more aspects of clipping circuits. In combinational two-level diode clipper, the signal is clipped to between two levels by using both types of diode clippers in combination. When Vi is more than Vb1, D1 is conducting. This is D1. And V0 is Vb1. When Vi is less than Vb2, D2 is conducting and V0 is Vb2. This is D2. In A is shown a two-level diode clipper that employs ordinary diodes. In B is shown two-level diode clipper employing two Zener diodes. In A, it is having diodes parallel. In B, diodes are series. The transfer characteristic of these diodes are shown here. In C, input and output waveforms are shown in D. Now we move to clamping circuits. These are used to establish the recurrent positive or negative extremity of a periodic waveform at some constant reference level Vr. Clamping essentially is altering DC level of a waveform. Notice the difference between clamping and clipping. Clamping alters the DC level of the waveform, whereas clipping alters the waveform itself. Out of clippers, we get a different waveform than that is fed. In case of clipping circuit, the spectral components of the signal, they are altered. In clamping, waveform remains same. Only alteration is in DC level. A simple diode version of clamper circuit is similar in topology to a clipper. with the resistor replaced by a capacitor. They fix extremity of input waveform at a fixed voltage determined by the biasing voltage instead of flipping them off. Based on their operation, clampers are divided into positive or negative. Another classification is into biased and unbiased. A positive clamp circuit, also called negative peak clamper, transmits a purely positive waveform from an input signal. It offsets the input signal so that all of the waveform is greater than 0 volts. A negative clamp is inverse of this. It transmits a purely negative waveform. Considering a bias voltage between the diode and ground which offsets the output voltage by that amount, clampers can be placed into 4 categories: positive unbiased, negative unbiased, positive biased, and negative biased. What are positive unbiased? Also called Villard circuit. In this, the diode is forward biased and conducts in the negative half cycle of the input, charging the capacitor to the peak negative value. During the positive half cycle, the diode is off and thus does not conduct. The output voltage is now equal to voltage across the capacitor plus input voltage. V0 is Vi plus Vi peak. Negative unbiased. The operation of this type of clamper is in the opposite direction to the positive clamper. In the positive half cycle of the input, the diode is on, charging the capacitor to the peak positive value. During the negative half cycle, the diode is off and the output voltage is equal to voltage stored in the capacitor plus the input voltage again. Some more points regarding clamping circuits. Positive biased. The functioning of a positive biased voltage clamper is same as the equivalent unbiased clamp, but with output voltage offset by the bias amount VB. V0 is Vi plus Vi peak plus VB. VB stands for bias voltage. Vi, capital Vi, this represents the voltage to which the capacitor is charged. V0 is output voltage, Vi is input voltage. Negative biased. The operation of a negative biased voltage clamper is same as an equivalent unbiased clamp, but with the output voltage offset in the negative direction by the bias amount VB. So V0 of t is Vi of t minus Vi peak plus VB. Here are shown 4 circuits. First circuit A is positive unbiased, B is negative unbiased, C is positive biased, D is negative biased. Consider A. Here also, in the case of clamping circuits 2, when diode conducts, when diode not conducts, this aspect plays a key role in finding the value of output voltage. In case of A, during negative half cycle, negative first half cycle, the diode conducts and capacitor gets charged up to voltage which is maximum value of the input signal. If the input signal is assumed to be sinusoidal, then the voltage to which capacitor charged is Vm. Vm is amplitude of the signal. After that, the diode goes to non-conducting state forever and the output voltage is input voltage and voltage across the capacitor, that combination, after taking proper signs into account. Same is the case in B with a small difference. During first half cycle of the input voltage, the diode conducts and capacitor gets charged to voltage Vm. Left side it is positive, right side it is negative. and then the diode goes to non-conducting state. Output voltage is combination of input voltage and voltage across the capacitor. The operation of circuits in C and D also can be understood, analyzed in the same manner. Waveforms, output waveforms are shown. In all these waveforms, it is assumed that input waveform is pure sinusoidal AC. It is like this. This is output in case of A, this is output in case of B, this is output in case of C circuit, this is output in case of D. C and D belong to biased clamping circuits. A and B belong to outputs of unbiased clamping circuits. Now we come to the end of this session. Let us recollect the important points that are touched upon in this module. Clippers are defined, clampers are defined. In the design of these circuits, the importance of diodes is explained. The functioning of clippers, the functioning of clampers, varieties of clippers, varieties of clampers. All those things are described and covered to a reasonable depth. Hope this session is useful to you. We meet again in another session soon with a new topic.